Alright, so today we have a 1200XL keyboard, Atari 1200XL keyboard, and pretty much none of the keys work. So without further ado, let's have a look and see if we can get this thing working. So the first thing we're going to do is take it apart, because the problem with these keyboards is there's a Mylar layer which presses down onto the PCB underneath, and there's a layer of silicone between the contacts on the Mylar and the contacts on the PCB, and that all works very well. So the problem with these keyboards is that where the Mylar, the fingers on the Mylar complete the circuit with the PCB, as you'll see when it's taken apart, when it was manufactured, for some reason they put a layer of adhesive at this point where the two circuits touch, and it was really unnecessary because the tension of the casing, the frame of the keyboard, holds things together really perfectly well without any adhesive. And of course this adhesive has degraded over the years, and it kind of swells up and cracks and just breaks the connection completely. So this part of the keyboard's fine, presumably, with the switches, so we don't need to do anything with that at all. So we can put this to one side. So here we have the part of interest here, and you can see it looks like kind of masking tape coloured thing. That's the adhesive, and that's all got to be scraped away. And usually the process of removing this damages these little silver traces here, such that we have to paint them on again. Sometimes it comes away cleanly, and all you have to do is scrape away the adhesive on the PCB, clean it up, put it back together. Job done. But more often than not, it's a little bit more complex than that. But it's not a terribly difficult job, and it's something you can accomplish easily enough if you have the right tools and if you just take care. So we need to get this Mylar off the board. You could kind of peel it up at the bottom here and work on it underneath, but that's a bit of a half-assed way of doing it. You really want this thing to be removed entirely so we can give the board a good clean. Now, of course, it's got some sort of mild tacky adhesive thing on it. So if you just try and rip it off, you're going to destroy it. It's going to pull the silicon layer. You can see these parts here where the adhesive is really gripping onto the PCB. I don't know if it is adhesive or it's some sort of surface tension that just came about with the pressure of the screws holding the frame tightly to the PCB, which has caused it to stick. But we're going to loosen this off with a bit of hot air. Nothing too hot. I'm going to drop the heat on this a little bit. 450 degrees is a little bit too warm. I think we'll take it down to about 300, because it's not going to deliver that much heat, but just take the edge off it a little bit. That's not too bad. That's just like a hairdryer. This is the hot air gun's rubbish, but it's good enough for this purpose. But this is one of the most time-taking parts of the entire process, is just removing this Mylar sheet. It's a real pain. This isn't the sort of magic solution, but if we're going to heat the whole board up, just get a bit of warmth into the board just to ease things up a little bit. Persuading this thing off the board without tearing it is quite an art form. So if you're going to try this yourself, this is going to be the most difficult part of all. It's not too hot. We can go in pretty close here. Let's get some heat into the back of the board as well. Right, so let's see how we get on here. Now a good tool is going to be a flat end screwdriver like this one, just to try and prise this thing off. And things like there's another handy tool is a guitar plectrum, a very handy tool with 1,000 uses. So we're going to start in the corner here, and we're going to see if we can persuade this thing off. Now you're going to watch carefully. You're going to see if we can get a view of this. Can you see? Come on, focus. You can see that this part here wants to stick to the board. So if we peel this, it's going to tear. So what I'm going to do here, this is just my way of doing it, is to work the end of the screwdriver. And doing this on camera is exceptionally difficult. Just to work ahead with this screwdriver tip to try and roll it along. I mean, you're going to get tears in it, there's no doubt about that. But if you roll it along like this, you see I'm rolling it along, roll it back again. So there, we've got a tear already, but that's not going to be a big problem at all. Now we've got another part here where it doesn't want to go. So we're going to roll it that way. You'll find sections that just come off really easily and others that don't, so we're going to get a bit more heat here. And you can see I've managed to save that bit. It was tearing from mine, so we're trying to get in behind the part that's starting to tear, and then we get this nice section that came off easily. Now I think we might be able to roll the screwdriver back on itself then and manage to save most of it. And this one's quite interesting because the adhesive's still kind of sticky, but it is causing the keyboard to be completely non-functioning. There we go, a nice big tear in that part. That's not a problem. Let's loosen that one up there. There we go. It's sufficiently far along that we can start to go in from the other edge now. Okay, nearly there. course, what you can do if you prefer, if this all seems a little bit torturous, is you can buy a replacement Mylar from, I believe, Best Electronics in the USA. So if you contact Bradley Coder, I'm sure he'll be delighted to send you a replacement. But there is not yet, I have not yet come across an original Mylar on a 1200XL which couldn't be salvaged and used again successfully like this. So I'm just flattening out these bits that were a little bit damaged. There we go. So if we have a look here, we can see what the problem is with this Mylar. If we get it into focus, the problem is these little yellow bits of adhesive which are preventing those black parts from contacting the PCB. Now the good thing about this one is because I've got very, very little conductive paint left, as you can see here. This is our conductive silver paint. It lasts for quite a long time, but I used to be able to buy this stuff at Maplin, which of course you can't anymore because Maplin went bust. But yes, this does the job quite nicely. So if we just roll these little bits of crap off the PCB and give it a nice little clean while we're about it. We can put this to one side because we don't really want bits of silicon lying around. I'm just going to rub these off with my finger. If there was major damage to the Mylar, obviously you would leave these parts on if there were huge swathes of it stuck to the PCB, but there's absolutely no need in this case. Now, removing this stuff from the board itself takes a little bit of scraping work, a little bit of scrapey. I don't know if the plectrum would be useful in this case. Yes, it would. We'll actually probably peel this off. And then we need to get in and get rid of all trace of this filthy stuff. And if you use a plastic plectrum, we're less likely to start scratching the board. And I'm just going to scrape all this away. I'll give you a close look at what's going on here, because I don't think I showed you. So this is what we're aiming for, just the bare contacts, and this is what we've got, this mess of adhesive which is pushing the carbon fingers away from the board, and we want them to touch nicely. Now this replacement Mylar you can buy from Best Electronics has this this sort of pad that you screw down to force the contact against the PCB, but I'm not entirely convinced that's necessary at all. There seems to be an idea that the glue is essential to press the two parts together, but I haven't seen any situation in which once these are fixed that any significant amount of pressure is really needed. This is what you're left with. This is what peeled off the. So this was it. It's an adhesive strip. It's most odd. It seems to have carbon fingers impregnated in it, so it was sort of an intermediary layer. But the good thing about this one, by the looks of it, is that it hasn't stripped the carbon fingers off the Mylar, so we may actually be able to get that off without using any paint in the process to repair them. So I'm going to clean the keyboard with a nice piece of kitchen towel or two. Some isopropyl. So we've got one nice clean PCB. Have a look at how those contacts look now. We can probably dig in a little bit further actually with acetone, just to really get rid of all the crap. Now the acetone absolutely pulverizes anything that's left on top of these fingers here. Gets them really clean, so we've just got rid of another little chunk. There we go. So those fingers contacts are super clean now, if you can see. So the board is prepared. So now we're going to turn our attention to the Mylar and see if we can carefully get rid of all this stuff here, which I think there's a bit of damage there. I think we are going to have to resort to the paint, unfortunately. Almost certainly. We'll see. Let's try and persuade this stuff off the edge of the board without damaging anything. That's probably possible. Right. We can always test it and see. That's what we've ended up with here. A couple of little breaks and holes in it, but I think that's worth putting back together just to see how it goes. And if not, we can always take it apart again and do a little bit more work on it. So I'm going to give this a try. Well, obviously we'll have to put a few screws in there in order to test it. Certainly not all of them. So let's give this a try. Okay, so now we've got this machine all set up with the keyboard plugged in, which we've just popped a few essential screws in the back. So let's power it on and see how we do. So we've got the Atari logo, and I believe the third key in is the help key, isn't it? Or is it not? Oh, there we go, that's the help key. Oh, there we go, keyboard test. Let's see what we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tab. Let's go full screen on this. 30. Of course, this machine doesn't have color yet. It still needs the super video modification. But it looks like we have a fully working keyboard. Control, Shift and keys, ZXC. Space bar. Start, select, option, function keys. Help, which will take us out of this. Break key never shows up, so help is that one. And we go. One fully working keyboard. which was completely and utterly dead beforehand. So there we go, that's how you fix an Atari 1200XL keyboard. I was lucky with this one because it didn't need any conductive paint. Probably a really bad example to pick for that reason, but I will be doing another one later on, possibly live, so with a bit of luck we'll have to go through the misery of using conductive paint in that one, which we didn't in the edited video. So hope that's been useful. Obviously we'll pop the rest of the screws in here, and the keyboard's going to be good for another 35 years hopefully. So hope you found that one interesting, and thank you very much for watching, and I'll see you in the next video.